Welcome to another fun-filled video of Math with Mr. Sims. This is the Cycle 7 Test Incentive video, and tonight we're going to go through some problems to get you ready for your test. Once again, I want to stress to you, this is really the least that you should be doing. If you're doing these, I'm glad you're doing them, but at the same time, remember that what you really need to be doing is all the study sheets so that you're fully prepared for the test. But that being said, let's go ahead and climb right in and see what we can do. So this problem here says find the slope. So the whole point of this one is to basically see, do you know how to apply the point slope, not the point slope, sorry, the slope equation to this problem. So let's go ahead and get started. Whoops, don't want to draw that. So I'm going to go ahead and write the slope equation. And I always suggest that you write the equations just so that you get the practice in. So y2 minus y1 over x2 minus x1. Oh yeah, and I gotta set Alexa to start. So in the upper right hand corner of your paper, here's what I want you to draw. In the upper right hand corner, you should have your first name and your last name. You should have your period number. You should probably at the title title it Cycle 7 Test Incentive. And right under Cycle 7 Test Incentive, I want you to draw a picture of a witch for Halloween. That's right. So Cycle 7 Test Incentive, then draw your best rendition of a witch for Halloween. Okay? Alright, moving on. Here we go. So m is equal to y2 minus y1 over x2 minus x1. Right? And what I'm going to do is I'm going to now I'm going to pick 2 points that I want to use. It doesn't matter which points I use. If I use these 2 points or these 2 points, they'll be fine, right? I like to pick numbers that work nicely, okay? But what I'm going to do is I'm going to actually pick one of the more ugly numbers. I'm going to use this negative number just so you get practice with seeing how it would work with that. So I'm going to label my numbers. This is going to be my y2 because it's in the y column. This is my y1. This is going to be my x1. Since this is my y1, this needs to be the corresponding x value for it. And this is the x2, okay? So now what I'm going to do is just plug it into my equation. So I get negative 3 minus 1, right? Negative 3 minus 1 all over x2, which is 16, minus 12. And if I simplify that, negative 3 minus 1 is going to continue down the negatives on the number line to give me negative 4, right? 16 minus 12 is going to be 4. So my answer is really negative 4 over 4. Now, if you're looking at that and you're thinking, okay, negative 4 over 4 looks like it can be simplified, you're right. In fact, because these are both 4, I can divide them both by 4. And your calculator will actually simplify fractions for you automatically if you put it in as a fraction, right? But if you didn't know how to do that, you divide both the top and the bottom by the same number, which is 4. So I'm going to get negative 1 over 1, which is really just negative 1. So my answer in this case is negative 1. And I'm done. So once again, what we did was we found the slope formula. Always write it down. And we put in the y2 and y1 over x2 minus x1. Then we simplified the fraction that we got, which was negative 4 over 4. We got negative 1. All right? So that's how you do that problem. Hopefully that made sense to you. Let's go ahead and move on to some arithmetic series now. So this one says an arithmetic series is given by the rule, f of x is equal to f of x minus 1 minus 4. And if f of 1 is equal to 18, find f of 4. So it gives me some really important piece of information. It tells me f of 1 is 18. It tells me they need me to find f of 4, and it tells me that this is my recursive function. So what I'm going to do is let's point out some important parts. This negative 4 right here is going to be my rule. In other words, what we're doing for each jump is we're going to subtract 4. So every time I jump to the right, I'm going to subtract 4. All right? Now, it tells me my first term is 18. So what I'm going to do, I'm just going to go ahead and make an f of 1. And they want me to find, so this is my first term here. This is first term, all right? I'm actually going to erase that so I have room. And this is they need my what term? They need my fourth number or my fourth term, okay? So they need the fourth term. So I got f of 1. I'm going to get f of 2, right? I'm going to get f of 3. And finally, that should lead me to f of 4. So these are all the pieces I need in order to make this work. Now, I know my rule is -4, so I'm going to start by putting my f of 1 is equal to 18 in. So this is not a fraction. What this is I made some spaces and I labeled them with these. So once again, not a fraction. It's just spaces that are labeled f1, f2, f3, f4, okay? So this space 18, I put 18. Now, to get to the next number, I've got to do a jump here, and in this jump, I'm going to subtract 4. So 18 minus 4 is 14. Minus 4 is 10. Minus 4 is 6. So at this point I end up with 6. So f of 4 then is equal to 6. So 6, this looks like a B. So 6 is my final answer. Perfect. All right. So once again, f of 4, we needed the fourth term. We got it. And 6 is my final answer. All right, let's move on to the next one. So at this point, here's what I want you to do on your paper. In the bottom right-hand corner, I want you to write math is the most awesome subject ever. Okay, that's what it is. Math is the most awesome subject ever. All right, that sounds great. Do that in the right hand corner. All right, bottom right hand corner. So factor this binomial. Factoring this binomial, what we're going to do is we got 9x plus 12 here. And when they say factor this binomial, I want you to remember that factoring really is the opposite of distributing. So when we distribute, or when we even do FOIL, right? We're doing, if we do the opposite of it, we're doing factoring. So opposite of distributing. So what I'm trying to ask in this case is, what is the greatest common factor that can go into both 9x and 12? In other words, so I'm really going to look at this 9 and this 12. And what I want to always focus on is the smaller of the numbers, because it's going to have less factors. I want to see which one goes into both of those evenly. So both this 9 and the 12 specifically, right? So I'm going to go ahead and draw my factors of 9. I'm going to put my 9 here. I'm going to write my factors underneath it. I got 1 times 9 will give me 9. 2 times nothing doesn't work, okay? So no 2. How about 3? Yeah, 3 times 3. And that's all my factors, because as you can see, anything else I'd get at this point, 9 times 1 is really just a repeat of the 1 times 9. So these are all my factors, and I'm going to start with always the biggest factor, because I want the greatest common factor. And 9 goes into 9x perfectly, right? But 9 doesn't go into 12. If I do 12 divided by 9, I'm going to get some decimal answer. That's not what I want. So then I'm going to try now 3. 3 goes into 9, and it also goes into 12. So what I'm going to do is I'm going to divide both of these. Sorry. I'm going to get rid of this and get rid of this. And like I said, I'm going to divide both of these by 3, right? And when I divide them both by 3, I end up getting, because I divided them by 3, I can actually pull them outside of the parentheses, because I divided both the terms by 3. So I can actually pull this outside the parentheses, that 3. And now, inside the parentheses, I'm left with whatever's left after we divide. 9x divided by 3 is going to be 3x, right? 12 divided by 3 is 4. Okay, so I get 3 times 3x plus 4. Now what's really cool about that is I don't have to guess if I got that right. I can actually, if I wanted to, I could actually distribute to see if I got it right. If I get the answer that I started with, then I know at least I did the factoring right. Now I might have more I could factor, but at least the factoring, I didn't make any arithmetic mistake, right? So 3 times 3x is 9x, right? 3 times 4 is 12. 9x plus 12 is what I started with. Therefore, I know that at least I factored out the 3 correctly. Okay? So anyway, so there we go. That's factoring the binomial. Remember, it's basically the opposite of distributing. All right, moving on. The slope of a line that goes through the points 2, 3, and 16y is 2, 7. Find y. All right. Alexa, how much time is left on my timer?
There are no timers set.
Well, whoops, I forgot to set the timer. So Alexa, set a timer for 23 minutes.
23 minutes. Start
All right, so that should give us about the 30 minutes. All right, here we go. So the slope of a line that goes to the points 2, 3, and 16y is 2, 7 here. So once again, my slope formula is m is equal to y2 minus y1 over x2 minus x1. And if I actually write these out, this would be my x1, this is my y1, right? This is my x2 and my y2. And my slope is this 2 over 7 here. So once again, I get 2 over 7 is equal to y minus 3 over 16 minus 2. Okay, so in this case here, that's going to be what I'm going to do now is simplify, right? Actually, let me get rid of that. I don't want to do it that way. I want to actually keep going down just so it's all clear here. So I get 2 sevenths is equal to y minus 3 over 16 minus 2, which is 14. Now, since I've simplified it that much, at this point, I have two fractions that, basically two ratios or two fractions on either side. And so what I'm going to do is I'm actually going to cross multiply here. Let me actually do it in different colors so you can see what's happening. So now I'm going to actually cross multiply here. And this one here, that was a 7, by the way, in case you missed it. And now that I've cross multiply, I should get 2 times 14, right, is equal to 7 times y minus 3. Well, I still want to get this y alone, and so since I have the 7 here that's being multiplied times it, I'm just going to divide both sides by 7. I cancel those out, and I get y minus 3 is equal to 2 times 14 is 28. 28 divided by 7 is 4, right? So 4 is equal to y minus 3. So at this point, I add 3 to both sides because I want to get y alone, right? I add 3. And what I get is I get y is equal to 7. Because it says the slope of the line that goes through the points, 2, 3, and 16y is 2 sevenths, right? So I put that in for the slope. Then I set up my equation for slope, y2 minus y1. y2 in this case is just y, right? And then they wanted me to find the y, so they wanted me to solve for this missing y here. And I get y is equal to 7. And I don't have to guess if I got that right. If I wanted to, I could actually put 7 in to the original equation. So I get is equal to, let's see, 7 minus 3, right, over 16 minus 2. Well, 7 minus 3 is 4 over 14, right, which is equal to 2 sevenths after I simplify. And isn't that what I got here? So yeah, I know I'm right. All right, looking pretty good. Let's go ahead and move on. Oh, let's move on to this one here. I think this would be oh, there we go. So which rule describes this arithmetic sequence? So I actually really like these arithmetic sequences are fun. Remember, an arithmetic sequence, there's a key to this arithmetic sequence, and that key in the arithmetic sequence is that an arithmetic sequence is adding or subtracting a constant to get the next term. So in other words, to go from here to here, I'm adding or subtracting something. That's why it's called arithmetic. If it was multiplying or dividing, it would be what we're going to learn a little bit later on called a geometric sequence, right? So in this case here, to get from -8 to -4, what do I have to do? Well, I have to add 4, right? So then if I want to get from -4 to 0, once again, I'm adding 4. And this will just keep continuing forever. It will just go on forever where each step is adding 4, right? So each step over and over again is adding 4 and adding 4 and adding 4, so on and so forth, right? So they want to know which rule describes this arithmetic sequence. So I got to find one where the rule is adding 4. Now if you look at these, remember this section here is the rule. So what I need to do is I need to look for one that has +4. If this was -8, then each of these jumps would be -8. So this one is out. This one here says +8. That means each of these jumps would be +8. That one's also out, right? So let's look at this one then. This one says f of x. In other words, if I want to get any term, then any term is equal to the previous term, right? Plus 4. So the previous term plus 4. Okay, that looks good actually. That looks really good. With f of 1 is equal to 4. So I go to my f of 1. This is not f of 1. Here's the 4 term, but that is not f of 1. That looks like it's f of 4. So that one's not it, right? F of 1 looks like it's negative 8. So what I need to do is look for one that has that. The last answer choice really that I have is this one here, D. F of x is equal to f of x minus 1 plus 4. Well, that's looking pretty good. I got my plus 4 for each term, right? That leads to each term. And it says the f of 1 is negative 8. So I have the starting term right as well. So this, in fact, is the correct answer, right? All right, sounds good. I love those arithmetic sequences. Let's move on. So this one's find the quotient. Ooh, this is more fun. So this one here is, once again, long division of polynomials. So I have 7x squared plus 23x plus 6 divided by x plus 3. So when you have a long division of polynomial, you do set it up like this, just like I did, right? And then you're going to follow the regular division algorithm. So what I'm going to ask is, and if you're struggling with this, by the way, I have a video on this where you can practice long division of polynomials to your heart's delight. But let's go ahead and really quickly just do this one. I'm going to ask the question, how many times does x go in to 7x squared? And so looking at it, I'm saying, okay, well, to get from x to 7x squared, I know I'm going to have to at least multiply by 7, right? Because 7 times x is going to give me 7x. But I don't want 7x. I want 7x squared. So it can't just be 7 times the x. I need actually to have this x to get the x squared term here. So now 7x times x will give me 7x squared. Now, remember, whenever you have a number up here, and you have to multiply here, you can't just multiply this times the x. I also need to multiply this times the other part of the divisor, which is 3. To say that a different way, when I multiply 7x times the divisor, what I'm really doing is 7x times x plus 3. So you think about distributing, I would have to distribute into there and there, right? So now I have 7x times 3 is going to be my 21x. 7x times 3 is 21x. And then, according to the division algorithm at this point, I should subtract, right? These will cancel out. 23 minus 21 is going to give me 2x, right? And I bring down the plus 6. Now I ask the question again, how many times does x go into 2x plus 6? And my answer is x can go into 2x 2 times. 2 times x plus 3, 2 times x is 2x, right? 2 times 3 is 6. And when I subtract those two, I get 0. And I'm done. 7x plus 2 was, or is, my answer. Now, once again, with these problems, you don't have to guess if you're getting it right. You can actually go ahead and FOIL to see if you got it right. So in this case here, I'm going to FOIL. I'm going to 7x times x is 7x squared, right? 7x times 3 is plus 21x, right? 2 times x is plus 2x, right? Plus 6. I add those two together and I get 7x squared plus 23x plus 6. And there I go. Since I started with that, I know that I did this right. Ding! And I'm going to get 100 on my test. Yay! Bada bing. Okay, moving on. So at this point, you should have underneath your... Okay. So what are we doing? So underneath your title, you should have drawn a witch for Halloween. In the bottom right-hand corner, you should have said something along the lines of math is the most awesome subject ever, or something like that, right? Or is the best subject ever, or something like that. In the bottom left-hand corner, I want you to write your favorite singer's name. Your favorite singer's name in the bottom left-hand corner, okay? Your favorite singer's name. That's it. All right, here we go. So, What are we doing? All right, so this one here, they want to know what is the inequality, right? I'm actually changing this problem slightly different than the study sheet. We're actually going to do a problem that's just a little bit harder than the study sheet just to make sure you're ready, okay? So if I were to ask you what is the inequality, right? Oh, that was ugly. So what is the inequality that's graphed, okay? That is so ugly, but just bear with me, okay? What is the inequality that is graphed, okay? If I want to ask that question and actually answer it, I've got to basically figure out what would my line be, and then from there I'm going to do something, right? So I'm going to look here. I got to find. Remember, if I'm going to make a line, y is equal to mx plus b, right? I need two things. I need my slope and I need my y-intercept, which is here, okay? So I need my slope and my y-intercept. I'm going to start with my y-intercept since that's a really easy one, right? So my b value, my v value is going to equal 1, 2, 3, and 4. So it's 4. My b is at 4, right? And my m value, I need to find two pretty points. Well, that looks like a pretty point to me. And let's see, another pretty point. That looks like a pretty point there as well. So what I'm going to do is I'm just going to zoom in here so we can do the counting. 1, 2, 3, up 3 and over 1. So up 3 and to the right 1 is the equation for my pretty point. So in other words, this is the slope of 3 over 1, right? And now that I know that those are my two pieces, I'm just going to make them the equation. Y is equal to 3 over 1 x plus 4. Now that would be my equation if I just wanted the line. But you'll notice that there's this shading over here. So that shading makes it not an equation. It makes it actually an inequality. Furthermore, this dotted line also makes it an inequality. So what this is saying is this. I'm actually going to erase these two things because it's actually not that. What it is it's going to be, first of all, because it's a dotted line, that dotted line is a lot like an open circle. It's telling me that it cannot actually be on that line, that it cannot be a solution on that line. So in that case, it needs to be either less than or greater than. I don't know which one it is. It's either less than or greater than. So to figure out which one that is, I need to look at the shading here. Now, I want you to imagine for a second you're a dude that's standing on this mountain, climbing this mountain right here. If you were climbing this mountain right here, you would say that this shading is greater than you or above you. So in that case, I'm going to put the greater than symbol. Y is greater than the 3x plus 4. So in other words, my equation is y is greater than 3x plus 4. And once again, we got that because the y-intercept is 4, the slope is 3, it's a dotted line, so we know it's not going to be equal to, right? If it was equal to, it'd have to be a solid line, but it's not. It's a dotted line, and it's shaded above, so we know it's going to be y is greater than that. So that right there is my inequality that's graphed on this one. Let's do another one. So this one here, if I have this graph right here, all right, so once again, for this one, we're going to do the exact same things that we did with the other one, right? We know that we want to get the equation y is equal to mx plus b, right? That's what we want to get. And once again, I'm going to look for my b and I'm going to look for my m. My b is my y-intercept, my m is my slope. So my y-intercept here looks like it's right here at 1, right, across to the y-axis at 1. And my slope, here's one pretty point, right? And another pretty point is right here. So it looks like to get from there to there, I go up 2 and over to the right 1. In other words, my slope is 2 over 1. So I'm going to get y is equal to 2 over 1, or just 2x plus 1. Now this would actually be my inequality and my equality if it was an equation, but we don't actually want an equation. We're actually looking at an inequality because of the shading here. The solid line's the same as it is in a regular line, but because of this shading that's right here, I know that my that is going to be an inequality somehow. So I want you to imagine for a second, if we want to figure out what it is, once again, you're standing on this line here, right? Just like you're climbing a mountain. And as I'm standing on that line, the shading is below me, or I could say I am greater than the shading somehow, right? So in this case here, y is going to be less than, y is less than you at this point, okay? The values that are possible are going to be less than you, but also because it's a solid line, it's going to be equal then, okay? So once again, because it's less than the line, because it's below you, you're going to put y is less than that. And because it's a solid line, this also has to be equal to. So the equation for this one would be y is less than or equal to 2x plus 1, right? Let's do one more here. So this one here looks a lot like the previous one, right? I'm looking at the slope here. Just knowing it's the slope, I know that the slope is going to be positive, right? Sorry, my slope is m. My slope is going to be positive. I know it's going to be positive, right? And I know that my b is going to be, in this case, my y-intercept is going to be 5. So that's my 5. And my slope is, it looks like that's one pretty point. That's another pretty point. In fact, so the slope, it looks like it's going to be 2 as well. So 2 over 1, right? So it looks like my equation is going to be y, and then it's going to be 2x plus 5, right? Now I just need to figure out the inequality here. Well, it's this dashed line. That dashed line tells me it's either going to be less than or greater than, and I have to look at the shading. So once again, I'm going to imagine that I'm standing on this line, and the shading is under me. So in other words, y is going to be less than all this stuff. So y is less than 2x plus 5. And that's it. All right, so we seem to be good. Once again, it's not going to be equal to because it's not a solid line. So, all right, so hopefully that made sense to you. You can get more practice on those with, I'm not sure if I have a video on that actually. I might. If so, check it out. So here we go. Which is equivalent to x squared minus 8x plus 15. Now at this point, you actually don't know how to do this. At least not the way that's the easiest, well, at least not the easiest way to do this. The easiest way to do this would actually be to factor this trinomial. But you don't know how to factor this trinomial. So for this one, you're going to do a workaround. And the way the workaround happens is this. We're going to take all of these numbers here, and we're going to multiply them together. We're going to basically FOIL them, right? And see which one gives me that. So I'm going to start with the first one. This is answer choice A, right? Answer choice A says x plus 1 times x minus 7. So I'm going to FOIL x times x is x squared, right? X times negative 7 is negative 7x. 1 times x is x, and 1 times negative 7 is negative 7. X squared minus 6x minus 7. That did not give me negative 8x. So in this case here, this is not the answer. A is out. Let's try B. B. So I get x minus 1 times x minus 7. In this case here, I get x times x is x squared minus 7x minus x, and negative times a negative is a positive, so plus 7, right? I'm going to add all those together, and I get x squared minus 8x. This is promising, but plus 7. Oh, never mind. Promise is gone. So and this one's also out because of this plus 7 here. This one was out for this and this, right? So let's go ahead and move on to C. C. Oh, whoop, didn't mean to circle that because I don't know if that's the right answer or not, to be honest. I get x plus 3 times x plus 5, right? And I get x times x is x squared, right? X times 5 is plus 5x plus 3x plus 15. And when I add that all together, I get x squared plus 8x plus 15. And that right there, x squared plus 8x plus 15, is so close. But what's it missing? This negative 8x. So this, because of that, is out. Now at this point, I'd be tempted to think it's just definitely D, but you always want to go ahead and work it out to make sure, because sometimes if it doesn't work out, then you made a mistake somewhere else, right? So x minus 3 times x minus 5. I get x times x is x squared. X times negative 5 is minus 5x minus 3x plus 15, because a negative times a negative is a positive. I get x squared minus 8x plus 15. And that is what I wanted. So my answer is, in fact, D. All right? So once again, if they give you all the answer choices and they're all basically all the factors there, you can FOIL them out. Okay? All right, let's go ahead and move on to this one here. The student council is selling candygrams. The total dollar value of the sales varies directly with the number of candygrams sold. The total value of the sales was 104.25 when 139 candygrams were sold. What would be the total dollar value of the sales when 240 candygrams are sold? So with this one here, what they're doing is they said that it varies directly. And whenever you see the word varies directly, I want you to think y over x. And so they give us a situation where the total dollars of sales was 104. Remember, the sales are going to come from the amount of candy you sell, right? So the sales are 104.25 is going to be my y value. So it's going to be 104.25, right? Over 139, right? And that's my y over x that you always see when you see varies directly, okay? Now, the thing is, though, it says what would be the total value of the sales when 240 candygrams are sold. So they're just not interested in this. They're actually interested in, what if instead of the 139 candygrams, we had 240 candygrams sold? Alexa, stop the timer. So in this case here, what I would do is I need to set up a ratio here, right? And this really actually is two. This is actually two of these together. What you really have is y1 over x1 is equal to y2 over x2, right? Where you have two that, since both of them are going to equal the constant of variation, right? The y1 over x1 is going to equal the constant variation, and y2 over x2 is going to equal the constant variation. I can actually make them equal to one another. So this is one ratio, and this is another ratio or proportion, right? So I got this one here and this one here, and what I'm going to put on top here is my y value. This is the one I don't know, because they're asking if 240 candygrams are sold, what am I going to get for y? So what I need to do here now that I have that is I'm going to cross multiply 104.25 times 240 and 139 y. And so what I get is I get 104.25 times 240 is equal to 139 y. And obviously now I got to divide by 139 to get rid of that, right? I get 139. So my y value then is going to be equal to this big mama jama. Now I'm going to go ahead and calculate that. I don't know that off the top of my head. That's getting to a big number, right? So let me go to my calculator. I get 104.25 times 240, right? And that's 25,020 divided by 139. That should give me 180. So when I calculate it out, I get 180. So when they sell when they sell 240 candygrams, they should get $180. Okay. The alarm rang, but there is, I think, one more problem that I want to get to. We can skip that one. Which Oh, let's do this one. This is the last problem I'm going to do for you, but I just want to make sure that you see it because this problem is a little bit evil, okay? So let me go ahead and work it through real quick. I got to get rid of this dot. It's driving me nuts. Okay. So this one here, it says the function y is equal to 3/5 x plus 1 is graphed to the right. What is the domain of the function when the range is y is greater than or equal to 1? So when the range is y is greater than or equal to 1 is what we want to be looking at here. And what I'm going to do, I'm going to change my color a little bit just to help. And y is greater than or equal to 1. At this point, y is equal to 1, right? My y value at this point is equal to 1, right? Now, when y is greater than or equal to 1, it's anywhere from this point on the line to really anything out there. All of this right here, the y value is greater than 1. In fact, you can see it. If this point here, this point would be 0, comma 1. This point here, let's get this point here. This point here would be 5, comma 4. Once again, my y value is greater than 1. So anything over here, my y value is greater than or equal to 1. Anything here. So I have to now look at the domain. What is the domain that gives me that? In other words, what are my x values that give me that? Well, we see the pattern of y being greater than 1 starts right here, and it goes all the way to really positive infinity, right? So x can be anything greater than 0, as long as x is greater than or even equal to 0, then that y value is going to be greater than 1. So my answer then is x is greater than or equal to 0, which is G. If I'd said x is less than or equal to 0, all those values, x is less than or equal to 0, would be over this way, and all those y values would actually be less than 1. Does that make sense? So anyway, that's how you solve that one. You basically figure out where does y equal 1 or it becomes higher than 1. And then you figure out what are the x values that correspond to make that happen, right? So anyway, x is greater than or equal to 0. Anyway, I hope you had a great time studying. It was a pleasure working with you. I wish you the very best on the test tomorrow. Remember, you can do it. You can do all this algebra stuff, and you can do so much more. It's all about just training your brain to do what you need it to do. So once again, you can do it. Give it your best shot. Tackle the rest of the study sheet. You can totally do this, all right? I wish you the very best, and I hope you have a great testing experience. Take care, and I'll see you next time.